So here's the first one, confidence interval for the difference of population means, use of the standard normal. This is the name of the topic in ALEKS. So that when you go back, when you get to it, if you're not there yet, you can find an example of that specific topic. I started doing them according to the topic so that you would more easily be able to find what you need as you're actually working through ALEKS. So here we have the Human Resources Department of a consulting firm gives a standard creativity test to a randomly selected group of new hires every year. So this our first sentence is just fluff. Okay. This year, 100 new hires took the test and scored a mean of 113.5 points, with a standard deviation of 14.6. Last year, 70 new hires took the test and scored a mean of 116.5, standard deviation of 14.6. Okay. Assume that the population standard deviations are can be estimated by the sample standard deviations, as the samples used were quite large. So quite large means generally more than 30, or 30 or more. So here we have a sample of 100 and a sample of 70. Okay, so we're going to be considering the difference between the mean test scores mu1 and the mean test score mu2 of new hires from last year. Then complete the table below, which of course is just the information about the lower limit and the upper limit of the confidence interval. So the difference in the population means is approximated by the difference in the sample means. Okay, so we're asked about the population means, but remember, all of this that we're doing with the confidence intervals is to approximate those values using the sample. That's what all of statistics is in general. And the sample statistic, the test statistic, is the difference of the sample means, which is x1, x bar 1 minus x bar 2, which means sample mean 1 minus sample mean 2, which in this case, our numbers are 113.5 minus 116.5, which is -3. So this is our sample difference. The difference of the two sample means, our test statistic, is -3, okay? So this is the mean that we're going to work around. Now remember, on this particular problem, we're looking for a confidence interval, but a lot of the things transfer from confidence intervals to hypothesis tests. So with all confidence intervals, we're really looking for the margin of error. And the margin of error, E, is found by multiplying the critical z-score by the standard deviation. Okay? Now for a difference of means, the standard deviation is given by this very lovely formula. I knew you would like it, and so I made it real pretty for you. Okay? It reads the square root of the variance of sample 1, which is standard deviation squared. The reason that the squared is on this expression is because variance is standard deviation squared. So this is the standard deviation 1 squared over that sample size plus the standard deviation squared of sample 2 over that sample size. Add those together and take a square root. So that is the standard deviation part of the margin of error. Okay? So overall, that's what we're going to look for first, is margin of error, but you need this part. Okay? Now remember, all of these formulas are given to you on ALEKS if you click the Explain button. What I'm trying to do is to explain it to you a little bit differently so that it'll make more sense to you. Now for the 90% confidence interval, which is what the question asked for, okay, see here in the problem, the question asks for a 90% confidence interval, and you need that when you go into it. So over here, then alpha is 0.10. Remember, alpha is the confidence level, 1 minus that confidence level. So 1 minus 0.90 is 0.10. So then you can use your ALEKS calculator to find Z of 0.05, and that's the score that cuts off one tail. Okay, let me pull up that calculator for you real quick. It'll take me a minute because I'm in the wrong class. There we go. So, so we'll multiply that z, that critical z-score, times that standard deviation that I gave you. So z times standard deviation 1 over n1 plus standard deviation 2 squared over n2. Okay, so I have gone into the wrong class. Okay, now I'm trying to pull up this calculator for you. I forgot to open that all up. It'll take a minute. Okay, so the z of alpha over 2, 0.10 over 2 is 0.05. So pulling that up on the ALEKS calculator gives you 1.645 is the critical z-score for a 90% confidence interval. Times, and see here's the square root sign. So times the first standard deviation was 14.6. So the first standard deviation was 14.6, and the second standard deviation was 14.6. The first n was 100, the second n was 70. So plugging that in, 14.6 squared over 100 plus 14.6 squared over 70 are our two standard deviations. So here's the calculator finally. There it is. On the calculator, you can go to the z and just plug in 0.05, and that gives us that 1.6448, which is 1.645. I know that that's very small for you, but here on the ALEKS calculator, you can see it. Okay, then just working this value out, 14.6 squared is 2.1316 over 100. 14.6 squared over 70 is 3.0451. And I'm going to post this PowerPoint so you can go back and check it yourself. And then adding those two together, we get 5.1767. The square root thereof gives the 2.27. And then adding that, multiplying that times the critical z gives us 3.7427. And that is your margin of error. E equals this value. Okay? So that's the sort of a fudge factor. A lot of times you'll hear on the news where it'll say, you know, this is valid plus or minus 3 points. Well, that's your margin of error. Whoops, I skipped over two things. So your lower limit, remember when we subtracted that, we got the difference of the sample means was -3. So your lower limit, you subtract that number and get -6.7427. And for your upper limit, you take that same -3 and you add that margin of error and get 0.7427. Okay, and then round it however ALEKS tells you to on that problem. Okay.